Hi, let's do a second video on a different STAAR test. First question. The table represents some points on the graph of a linear function. Usually linear means slope-intercept form. It is a line, that's why it's called linear, but there are several forms. The most usual one is the slope-intercept form, y equals mx plus b. We have the table. As we look at the options, we see that the options resembles the slope-intercept form. So this is the one that we're going to be using, y equals mx plus b. And we are asked to figure out which function is best represent this relation. There are several ways of doing that. One way would be to put this function one by one on the graphing calculator, and here of course I'm gonna focus on the on using the graphing calculator heavily. One would be to put these functions one by one and find their table and see which one gives me the table that matches that table. Let's start with this method. Okay, and I'm gonna give that first option to the graphing calculator. Y equals negative 3 over 2x plus 4. We have y equals negative 3 over 2 x plus 4, and then we have a table. Now in this table we're gonna get generic points from negative 2 to 2. We know that for a line we only need 2 points, but we have to match at least 2 of them if we don't want to input the third one, but I'm just gonna put all of them. Negative 4, negative 2, and 6, and the calculator is gonna give me the values. I have negative 2. Now let's put negative 4, the next one 6, and let's get rid of the rest. So negative 2, 7, negative 4, 10, 6, negative 5. And it turns out that this is the correct answer because it gives me that table. Now of course there is another way, and that other way would be based on the table to figure out what the function is, and then give the function. That would be also the only way if I didn't have options, or if that my preference was. How would I solve this in the second way, that I start with the table and I get the function? Now the table has 3 points, 1, 2, 3. In order to do a line I only need 2 points, so potentially I could focus on 2 of them only, not on the 3 points. Sometimes they may give me 10 points. Why should I spend the time to input 10 points when I only need 2? But if I don't see it, or if I don't think of it, and you put all the points, that would be fine. Okay, so let's go to our graphing calculator and see how we're gonna do that. With a graphing calculator, the one way of doing it, which is what I'm gonna do, is with the squiggly method. Basically we create a table we call x1 and y1, and then based on the data from this table we are going to ask the graphing calculator. How do we ask it? We ask with a squiggly. Instead of equal sign we put a squiggly. We ask the calculator to estimate the the linear function that is represented in this table, and when the points are perfectly accurate, the calculator's estimate is going to be perfectly accurate. How do we refer the calculator to this data? This y is y1. When we create a table, it's going to be called x1 and y1. So this y is y1, squiggly, m is m, x1 plus b. So this y1 refers to this data. That's our way to direct the calculator to where it's going to get the data from. And this x1 refers to that data on x1. And what are those data? It's exactly the data that are given to me. And if I don't see that I only need 2 points, then I can get. Just remind you that this one refers to the point negative 4, 10. This one refers to the point negative 2, 7. And this one refers to the point 6, negative 5. Where in the first place we got the x, and the second place we have the y coordinate for each point. Okay, so let's do this. Let's go to our graphing calculator. And let's see what happens. Make a table. In this table, I'll plug in the points that are given. Negative 4 goes with 10. Negative 2 goes with 7, 6, and negative 5. Then y1 squiggly, m, x 1 plus b. When I do that, I see that the slope is equal to negative 1.5. This m, as we saw earlier, is the slope. Then b is equal to negative 4. If I want to convert this 1.5 to a fraction, that would be negative 3 over 2. So we have negative 3 over 2 and 4. Let's see. We have y equals mx plus b, with m equal to negative 3 over 2 and b equals to 4. So what we get is negative 3. We get y equals negative 3 over 2x plus 4. If we look to the left, it's option A. Let's go to the next one. The water level in a tank is charging at a constant rate. Okay, what is that constant rate? That it refers to the slope. Rate or rate of change when it comes to graph is the slope. And what does the constant mean? Let's go one by one here. The rate is the slope. When it says constant, that means it's just a line, because only lines have a constant slope. The graph shows the relationship between time in hours, x, so x is time, and water level in meters, so y is meters. Okay, what matters is that I have x here, y there. Let's see what they're asking you to do. Complete the statement that describes the rate of change. Okay, that describes again the slope of the water level with respect to time, always with respect to whatever is on the x. Move the correct answer into each box. Not all answers will be used. So here we'll have to this one, as once we press it, it's gonna give us some options, some numbers. Here is gonna be increases, decreases, and here is gonna be some other numbers. Okay, so obviously the first box is the long one, is gonna be a word, and we have to choose whether we put increases or decreases. How do I figure this out? Well, I figure this out just by looking. When I move from left to right, the way I write, I always write from left to right. Does it feel that I'm going down or up? And you see that here it looks like you're going down, considering this is the ground. So here the answer is decreases. Okay, so here you will choose to put decreases, or you will move that box here after you select decreases. At a rate, again, that's the slope. Now we'll need to find the slope. To find the slope, we need basically to find the entire equation using the squiggly line, the squiggly method. To do that, I need two good points. That's a good point, the y-intercept. Always x is 0 for the y-intercept. So 0, y-intercept, that means is 0, 9. And another good point, looks like this one is exactly in the middle. They haven't emphasized it, but I hope that this is what it means. So the coordinates here is, let's say the x coordinate is 4, the y coordinate is 8, and the x coordinate goes first, so you're gonna put 4 first. The x coordinate is before y in the alphabet, so it's gonna go first. 4, 8. Okay, that's the x, y of that point. Now what do we do with these points? I get a chart: 0, 9 and 4, 8. Once I have the chart, I can find the equation, and of course that means I can find the slope as well, and everything. So 0 goes with 9, and then we have 4 that goes with 8. Again, I'm gonna ask from the calculator to help me figure out this equation, and there are other methods as well if you want to do it by hand. Plus b, and it will tell me that the slope is negative 0.25. I'll convert it into a fraction, so I'll have to see what they want. Do they want the decimal number or do they want the fraction? What matters here is that, whoops, I missed an E. What matters here is that I found that the slope was 0.25, and in particular was negative. If you hadn't realized that the graph was decreasing, once you see the negative in the slope, that means it's decreasing. So whatever numbers they have that you can combine here, if they want you to plug in the decimal, you put the negative 0.25. If they want you to put a fraction, you put the negative 3/2. If they ask for the equation would be negative 3/2x plus, I think I forgot to write the b. b was equal to 9. Okay, let's double check that I have everything. I expected b to be equal to 9 because that's the y-intercept. And okay, so the equation would be y equals negative 3 over 2x plus 9. If they want the decimal, then it would be negative 0.25x plus 9. Okay, next one, the graph of a quadratic function. Okay, quadratic function. Usually we have several forms of a quadratic. The most frequent is the standard form, so I expect something like that, but that doesn't mean that this is what they want me. This is the form that they want. If I look at the answers, I see that yeah, this is the standard form that they are looking for. Okay, I see the graph of a quadratic, which is a parabola, a U-shaped curve. Which function best represents h? Okay, so I need the which function is the correct one. And here I don't have to look for the equation. I just need to plug in one by one and see which one gives me this graph. To have a better to avoid making mistakes, because the scale may be wrong, you can either make sure that you have the same scale, meaning each box on the horizontal and or the vertical, they count for 1, or probably together. You can double check. Find some points that you expect to see on the correct graph. Let's start with this point. That's the x-intercept. So you expect the y to be 0 and the x-coordinate would be 1. That would be the coordinates of this x-intercept. There is one more. Again, the y, put it 0 immediately so to avoid making little careless mistakes. That would be the y-intercept. So x is 0. And that would be the points that you expect to find on the correct answer. Alright, we'll go one by one. Let's start with the first one and see if we find it good. If not, we go to the next one and so on. X squared plus 2x minus 3. Y equals x squared plus 2x minus 3. Okay, that looks pretty close. Let's tap those points. 1 0, negative 3 0, 0 negative 3, and oops, and those are the points that I have. Okay, so that's the correct answer. Let's move on. We got number 4, rectangle. Oh, rectangle. Okay, has so what is the shape of the rectangle? That is a rectangle. Let's see if it can, the system will help me here. Okay, so this is a rectangle. It has length. The length is 5 plus 2x inches, and width 10. Okay, so that's the width and the length and width. A triangle. Let's see if I can help me draw a triangle here. Okay, so that's a triangle. Has base 30 inches and height. What's the height now? To find the height, go from the vertex that's opposite to the base and draw a perpendicular line. So this is 90 degrees. Okay, the length of this height is 4x minus 10. Okay, the area in square inches of the rectangle. So here the area of the rectangle is equal to the area of the to the area in square inches of the triangle. So those two figures have the same area. Okay, so what is the value of x? Okay, we're looking for x. Where is x? X is here and here. Well, here we need to know a little bit of geometry, and in particular we need to know the formula for the area of the rectangle. Let's call it area 1, and this call it area 2. So, but we have that area 1 is equal to area 2. What is area 1? The area of the rectangle is basically length times width. Okay, so that would be 5 plus 2x times 10. Always that's the area of the rectangle, length times width. So that's length times width. Let's write it more carefully. Times width. Okay, with the area of the triangle is base times height over 2. So the area of the in our case, length is this, width is that, so we have 5 plus 2x in parentheses times 10. Then in our case we have base, which is 30, times the height, so I'm going to put it in a parenthesis, 4x minus 10 divided by 2. Okay, and now I have my equation, and I will try to put it on my calculator. Okay. But how am I going to do that? Let me tell you. The way we're gonna use the calculator, we're gonna convert this equation into a system of equations. So we're gonna have y equals the left hand side, 5 plus 2x times 10. Then y equals the right hand side, 34x minus 10 over 2. And this is what we're gonna put on the calculator. And to solve that system, we'll see where the intersection is. Each one of those is a line, and we'll see where the intersection is. That's gonna give me the solution. Okay, so let's see how I'm gonna do that. Let's go here. First I'm gonna put y equals the area 1, or the left hand side. Let's write it carefully. Is 5 plus 2x in a parenthesis, and then it's times 10, and that's gonna give me a line indeed. Okay, now let's go and do the same for the right hand side. Y equals, we have a fraction line involved, and then we have parentheses 4x minus 10. Oops, let me see. No, we put the 30 first. We put the base first, so let's do it exactly the same. 30 times parenthesis 4x minus 10, and then we divide it by 2. That's going to give me another line. I have to change the scale a little bit so I can figure out, locate the intersection. And what do you think I'm looking for? Where I'm looking for the x. The x is on the first place, so that's 5. Okay, and I see that the answer here would be that x equals 5. And I look at the options. That would be option D. Alright, let's go to the next one. We have the following. Number 5. Which expression is a factor of that? Okay. We're referring to factoring this quadratic. When you and this is in the standard form, y equals ax squared plus bx plus c. When you factor it, you get an equivalent form. That is the factor form. In general, it can look like that: x minus u, x minus v, and that u and v, those are the x-intercepts. So a factor would be related to the x-intercept, and if I solve this factor, I'm gonna get the one of the or that factor, whichever is the correct one. I'll get the x-intercept of the quadratic, of the given quadratic. So how am I gonna use the graphing calculator for that? Well, let's see. First of all, I'm gonna write the function given y equals, even though it's not given y equals, let's write it properly. 30x squared minus 4x minus 16. Okay, I have the quadratic. I confirm that there are x-intercepts, because if there are no x-intercepts, then it cannot be factored. Okay, I don't need the x-intercepts for what I need to do. Now I'm gonna put the given factors one by one, and I'll see which one, and I'll get a line for each one of them, and I'll see which one, which line has the same x-intercept as my parabola, my U-shaped curve. Okay, so let's do that. Y equals 5x plus 4. Looks like it's really close, but that's not it. Let's go to the next one. Y equals 3x minus 2. Let's see. It's pretty close, but it's not it. And then y equals 5x minus 4. 5x minus 4 looks like this one. That's the one. As I said, its factor is going to be associated to an intercept of the curve, and whichever factor corresponds to a line that crosses at the same intercept as the curve, this one is going to be the correct one, and it's the 5x minus 4. So we go here and we see that this is the correct one. Okay, let's do the next one. Number 6. The table shows the number of species added to the United States endangered species list each year for several years. A linear function. Okay, that's our first keyword. Y equals mx plus b. Can be used to model. Model, that's another keyword. It may not be exact. It may be a best fitted line that I'm looking for. That means I'm going to put all of this data in, not just 2. If it's an exact line, then I put 2. If I sort of look at the graph and I can find 2 good points, that's all I need. But if it's a best fitted line, that means that there may be many points that go like that, and I have to approximate what the best fitted line is that goes sort of as close as possible to each one of those points. So it's going to be somewhere in between. Okay, and it could be decreasing. It could be decreasing like this one, or it could be an increasing line. It can go like that, and I need to approximate. We'll see what happens. Okay, but I'm gonna have to use all the points. That's the bottom line. I'm not gonna use just 2 of them. Okay, which correlation best describes the strength of the linear? Okay, I see some keywords here: correlation and strength. Those have to do with this correlation or regression factor, and we're gonna see how that looks on the graph and on the calculator. Let's read the whole thing. Which correlation best describes the strength of the linear association between the number of species added to the United States endangered species list and the year? Okay, let's look at the answers now. Weak negative correlation, weak negative correlation, strong negative correlation, strong negative correlation. We have weak and strong, and then we have positive and negative. We have, you see here, it's negative, 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 negative. We don't have any positive. Okay, so we're not gonna have to worry about this. We see that they're all negative indeed. So positive and negative means what is expected, plus or minus. Okay, now weak means close to 1. Weak means close to 0, and strong means close to 1. Positive strong means close to plus 1. Negative strong means close to negative 1. I think I put those backward somehow. So positive means plus, negative means negative, okay? And weak means close to 0, strong means close to 1. Now, what do we have here? We can't really tell just by looking at the table. We have to look at the graph. Now, let me draw a little graph for each case, and then we're going to look at the calculator. A weak could be, and since we have all negative here, I'm going to draw a negative weak, something like that. We see that if we try to approximate with a line, we're kind of missing a lot of points. There are points everywhere. They kind of go downwards, but they're not following the line. Now, so here would be negative weak. Now let's do a negative strong. A negative strong would be kind of very close, follows closely to a line. It tries to align with it. It doesn't succeed 100% exactly, but it's very close. Okay, so that would be a negative strong. It could be, for example, negative 0.9, like close to 1, and negative, so close to -1. Here it could be the value for the week could be maybe negative 0. I don't know, 1, for example. All right, now let's see what we got in our case. Let's make a table and we'll put the years. Before I do that, let's call the years X and the endangered species Y. So we have 2011, 19, 2012, 51, 2013, we have 89, 2014, 66, 2015, 31, 2016, 74, 2017, 11. Okay, let's see what we got. If we have some now we really have to change the horizontal scale. And how do we do that? You see this plus on the bottom of the table on the left. If I click that, it's gonna give me those points. Okay, so this is what I get. Just by looking at it, I can tell that this does not try to align to closely to any line, so it's gonna be weak. Now whether it's going down or up, that's still not clear, but what can I say? You can see at least that the last years it's kind of going it's kind of going down a little bit, the recent years. Let's see what happens. Let's see what if we do the calculation using our math, what we would find. Okay, so I'm gonna put y1 squiggly m x1 plus b, and it tells me that it looks like it's not clear because it's very weak, but it looks like it's going downward. And you can see when you go to the left side, it's kind of more spreaded than the points on the right side, and it kind of tilts. So we can believe it. Now let's look at the new tab. Let's look at this R. We're gonna look at this R, which is negative 0.09. Indeed is negative because it's decreasing and all that. And then is 0.09. Now 0.09 is really close to 0, so it's negative and weak, and we can tell that it's weak because they don't try to align. We can tell that it's negative because it's decreasing. So our answer, our option here would be definitely weak and negative, and we have between this one and this one. Now we have the exact number as well, and the exact number is 0.09, negative 0.09. So the answer is B. This one 0.9, that would be strong. Okay, because 0.9 is close to 1. So it says weak negative, but it gives us a strong one. So that would be wrong. Okay, so here's the correct one. Okay, let's go to the next one. Number 7. A part of a linear function. Okay, linear, again, y equals mx plus b is shown on the grid. And we have 2 points emphasized. So here is the coordinates of this point. The x is -2 and the y is 2. And here are the coordinates of this one. The x is 3 and the y is -4. Okay. What is the range? Okay, the range of the part of the linear function shown. Choose the correct answer from each drop-down menu to complete the sentence. The range is the set of all real numbers. There is something missing here and something missing here. So we will find the range and then we will see what goes there. Now, they could also ask for a domain, so I'm just gonna find both. Alright. Also, because they ask for a range or they could ask for a domain, it's important to notice that one of those 2 points is a little circle. That means it's a hole. This point is missing from the graph, and that corresponding point is going to potentially be missing from the domain and potentially be missing from the range as well. Alright, well, domain and range. Domain has to do with x, range has to do with y. Same order as in the alphabet. X goes with D, Y goes with R. X has to do with the inputs in case the problem calls it inputs or outputs for X and Y. Inputs are on the horizontal. Horizontal means going left to right, like the horizon. And output or Y or range has to do with the vertical axis, which goes up and down. So horizontal means, let's reduce the words here, left, right. Vertical means up, down. Now here they're asking for the range. How do I find it? I project on the vertical axis. So I'm gonna follow this line, projecting on the vertical axis. If I do that, I see that this circle here, which is a hole, it projects to nothing, so I'm going to put another hole here. But all the other points are going to end up on the highlighted part of the vertical axis. Now I need to know this number more precisely. So let's erase part of it. So I have this number, which is -4. So this -4 is going to be excluded, but it starts with -4 and goes all the way up to 2. How do I put that? Put it like that. Y, and it can touch 2, but it cannot touch -4 because there is a hole at -4 is the projection of a hole. If there is missing, its projection is going to be missing too. Okay, so we have Y is going to be below 2, it's going to be less than 2, but it can touch 2, so it can also be equal, and it's above -4, so it's greater than -4, and it cannot touch it. So that would be the range. Usually we put those in braces, and let's write it like that. Okay. And in case anybody sees the spelling of it, range and domain. Now, suppose that I was looking for the domain. What would I do? If I was looking for the domain, I would project. Let's not erase that. I would project on the horizontal. If I was looking for the domain, I would project on the horizontal axis, and I would follow the entire line, and I would project like this, and the hole would project to nothing, so there would be a hole here. That would be 3 and -2, and the part of the x-axis that would correspond to the domain. In other words, the graph of the domain. This is the graph of the domain, and this was the graph of the range. Well, the domain is between -2 and 3. It's to the right of 2. So if to the right of -2, so x, which goes with the domain, and earlier, of course, we had to use y with the range. So x is to the right of -2. That means -2 is less than x, or x is greater than -2. That's the same thing, but it can also be equal, because there's it projects from a point that is included, so the projection point is also included. We're talking about the -2. The 3, though, there's a 3 here, which is greater than any x on this part, but it cannot be equal. So the x is between -2 and 3, is less than 3, greater than -2, and it can also be equal to -2. So that would be the domain if they were asking for the domain. Sometimes they could ask for both. So here, how would we choose? The range is the set of all real numbers. So there is a little s missing here. All real numbers. Here would be greater than. Here is greater than -4, and less than or equal to 2. Okay. You see the y is greater than -4 and less than or equal to 2. This sign has the greater on the big opening and less or smaller on the left, where the opening closes. Okay. So I'm just gonna put smaller here, which is less than. Alright, let's go to the next question now. We are at number 8. Which statement about this is true? That's a quadratic, and we need a true statement. Okay, sometimes they could ask you for which statement is false. Okay, the zeros, what are those zeros? Those are the x-intercepts, are this and that, because this is equal to that. So it kind of factors it. It takes this function, which is in the standard form, and it factors it, and it writes the factor form here. One of the factor forms, it's not the first factor form we do, but we see it has two factors, one factor times another factor. Okay, and usually each factor reveals the zero or the x-intercept, so that's why it kind of the factor form is very closely related to the zeros. Now, what's important here is that it's giving us two equivalent forms. One is the standard form, and the other one is the factor form. And those two has to be equivalent. Otherwise, the zeros of one would not be the zeros of the other, and I wouldn't try to find the zeros of one by finding the zeros of the other. So, if they are equivalent, what do they have? Not only the same zeros, they have the same chart, they have the same graph, they have the same everything. And I'm going to try to find which one of those options has the same graph as the given one. Okay, let's do that. Let's start with a given one. Y equals 4x squared minus 36x plus 81. Admittedly, it would be a little faster to do it by hand here. How would we do it by hand? We would have to take one by one the given expressions and distribute and see if we would match the standard form. Alternatively, I would try to factor this standard form, but in the stress of the STAAR test, our brain may not want to do all this work, so I'm just gonna do the graphing calculator. Another thing is that when you put this on the graphing calculator, they are all called f of x. Oops. But it doesn't, that's just the y. That's another name for the y. Unless they ask you to calculate the f of 10, for example, you don't need these notations, and I'm gonna replace it by y. Okay, so let's go with the first option. Where is my graph, by the way? Oh, I can narrow it down now because I see there is only one x-intercept. And this x-intercept is the 4.5, which if I write it as a fraction is 9 over 2. So now I can potentially narrow it down a bit so I don't have to do all this. There is one x-intercept, which is the 9 over 2, and I see that that's only in option B. There is a 9 over 2 here, but it's giving you plus and minus. So the correct option is B. So instead of putting all of those one by one, and I'm just going to put the first one just to see that we don't get the same graph, in case we don't realize we don't realize that there is a way to narrow it down, and we do the work. Let's see what we would get. Okay, I'm just going to put the first one, and then I'm going to put the last one to confirm. Okay, let's do the first one. Y equals 4x minus 3. It's 4x minus 3 times x minus 27, x minus 27. Where is that graph? Oh, let's change the color a bit. Make it pink. Oh, the other one is pink too. Never mind. Let's make it blue. And it's definitely not it. Okay, it's definitely not it. Now let's put the last one that I have already figured out that it's the correct answer. Y equals parenthesis 2x minus 9 squared, and looks like I get the exact same graph, and this is how I would find it if I hadn't realized that there was a way to narrow it down. Okay, now let's go to the next one. 9. What is the equation of the asymptote of the graph of the function this? This is an exponential. Okay, that's an exponential, and look, it has this form: y equals a times b to the x. And we've seen before that a is the initial value of whatever it represents. On the graph is the y-intercept, b is the base, sometimes it's called also growth factor. And in every step, every generation, or whatever that x expresses, every year, every month, you multiply times the growth factor, and that means you get an exponential. That's an exponential behavior. Okay, so you multiply, you don't add a constant number. If you add or subtract a constant, a fixed number, that's going to be a line. If you multiply by a fixed number, that's going to be exponential. Okay, now what is it asking for? What's the equation of the asymptote? That's the asymptote of the exponential. Now exponentials can be increasing, they can go like that, or they can be decreasing. In either case, they demonstrate an asymptotic behavior. Asymptote means you try to reach, but you cannot reach, and you can never touch. And that is on the left side here. As it goes down, it tries to touch the ground, but it can't. And it goes closer and closer. Eventually it aligns with the ground, but it can never touch. On the other hand, here is on the right. It goes down and it tries to touch the ground, and it cannot, but it goes closer and closer, and looks like it eventually aligns with the ground. And in each case, the asymptote is the ground. This is the line that you cannot touch. In each case, the equation, because the ground is at zero height, the equation of the ground or the equation of the x-axis is height equals 0 or y equals 0 in either case. The only time that you wouldn't have the ground as the asymptote is if the exponential would be shifted up, then the asymptote would be shifted up, or it would be shifted down, then the asymptote would be also shifted. Now, how would that look like it would be plus something or minus something. Let's say a C. If you go up or down, that's the only case that you wouldn't have this asymptote. And it looks here that there is no plus or minus anything. We expect that the asymptote is the ground. But let's plug it in and see how it looks like. So y equals 16 times parenthesis, I'm going to write it exactly the way it is, 0.75 to the x. And it looks like the asymptote is on the ground. It hasn't shifted up or down. If I zoom out, you'll see that it kind of tries to align with the ground, and you're like, oh, does it not touch it eventually? No, if you change the scale, no matter how far you go, you'll see that there is still a gap, meaning it tries to touch the ground, but it will never touch no matter how far you go. But if you zoom out, it will appear that it's really close and it's aligning with it. Okay, so what is the answer here? The answer is that the equation of the asymptote, y equals 0. Okay, and that's always going to be the asymptote unless you see an exponential that has plus or something or minus afterwards. What if you have plus 1? Then it's going to go 1 up, and the asymptote is also going to go 1 up. Then it's going to be y equals 1. What if it's minus 1? Then it's going to go down, so the asymptote is going to go down. It's going to be minus 1. And just in case you see something like that, let's put a plus home here. Okay, now let's duplicate this and also put a plus I don't know, plus 2, and change the color. You see that it has going up, and if you follow that line, it should go through 2. Okay, that's that would be the new asymptote. Okay, now let's go to the next one. Okay, selected response. We are in question 10. Which expression is equivalent to this one? This, that, or that. That seems very tricky. And again, admittedly, it could be easier to do it by hand. Here this 2 is going to distribute to the exponent, or is going to multiply the exponent, and 2 times 3 you're gonna get 2 times 3 you're gonna get a 6/7, so kind of the answer is gonna be 6/7. But if you don't know the properties of exponential, if you don't know that when you have the power of a power, the two exponents multiply, how would you do it? Well, this is how you would do that. First of all, you would convert each expression into a function. How do we do that? Y equals, then I would write it exactly the way it is, x to the it's 3/7, so it's 3/7, then close the parenthesis, and all of it is squared. Oops. Let's see how I'm going to do that now. it doesn't. Okay, let's see. Let's see what the next one is. I know that it's gonna be y equals x to the 6 over 7. So let's see if that graph, how that graph looks. Oops. And we got a matching graph. Now, what if I put one that is not correct? The first option was, so I kind of confirmed that what I expected, that this C is the correct answer. What if I put this one, 6 over 14? Let's see what happens here. And why they are giving me those two options, 6 over 7 and 6 over 14. They want to see if you try to utilize the properties and you try to multiply 3 over 7 times 2. Are you going to know that this is 6 over 7? Meaning, are you going to just multiply the numerator after the numerators after you convert the 2 into fractions? So 3 times 2, 6, 7 times 1, 7. Or you're going to write it like that and you're going to multiply both of them and you're going to write it 6 over 14. So this is a way to test whether you know how to do it by hand. But at the same time, we have the graphing calculator, and let's see what happens when we put the wrong answer here, 6 over 14. So x to the 6 and 14. We see that it's not the same, okay? We see that it's not the same. That's the correct answer. Okay, so let's move on. So that was a matter of either you kind of know it or you try to plug in one by one. Just make sure you know how to type this, okay? Because it's going to be tricky. It's not going to look like this 2 on the calculator looks a little bit lower. It's still not times 2. It's to the second power. Okay. 11. Which statements about this function is true? Well, this is a quadratic function. Okay, y equals ax squared plus bx plus c. Which statement is true? Okay. Sometimes they ask you which is false, so it's true. Let's go over those statements real quick to see what to expect. The domain of the function is that. I know that this is wrong because quadratics always, the domain of the quadratic is always all real numbers. There is no exceptions unless they restrict it and they tell you, oh, don't go anywhere, everywhere that you can. Just go from here to there. Then the domain is all real numbers. So let's take a quadratic. The domain you have to project on the x-axis, and because it's expanding forever, you keep projecting forever, and eventually you will cover the entire x-axis. So the domain is always all real numbers. Okay. Now the range is going to start from the vertex, and it's either going to go up or start from the vertex and it's going to go down. Okay, so it's either going to go up or start from the vertex and it's going to go down. So the vertex, the range is not all real numbers. But let's see. Now we have this particular quadratic. Let's see, they give me the domain, the range, the domain. I know that those are going to be wrong because it restricts the domain. So it's probably one of those two. And let's look at the graph. Let's look at the graph, and we have y equals 5x squared minus 20x plus 12. Okay, you see that because it opens forever, eventually it covers all x-axis. At the same time, the range is going to start from the vertex, which is at 2, negative 8, and it's going to go up. So it's from negative 8 and up, including negative 8. And that is negative 8 I only have here. It looks like it's going up and can be equal to. So all the y's, but why is it calling it n of x? Well, because it calls it n of x, but n of x is the y. And that's why the range which is associated to the y is that y greater than or equal to negative 8. So that should be the answer. Okay, no matter if it calls it n of x, that's the y. Next one, number 12. A customer is ordering hats and t-shirts from an online store. Each hat costs $7, so hat $7, and each t-shirt costs $10. The customer receives free shipping if the amount of order is over 100. Now, what does over 100 mean? Over 100 means greater than 100. Write an inequality that represents all possible combinations of hats. So hats is X, and t-shirts Y in an order that qualifies for free shipping. Move the correct answer to each box. Not all answers will be used. Okay, well, let's make it a bit more fair and erase that. Okay, so we know it's going to have to be greater than 100, otherwise we're not getting free shipping. Now hats is X, and each hat costs 7, so it's going to be 7X. That's how much you're going to pay if you buy X number of hats. And a t-shirt is going to be Y. So Y, and how much does it cost? 10. So plus 10 greater than 100. So what do we put here? Put 7x plus 10y greater than 100. Okay. Number 13. An experiment examine the relationship between the number of miles a car traveled. So y is miles per gallon of gasoline and the speed of the car x in miles per hour. The table displays the data. Well, you may want or not to know what they represent here, because it clearly put the x here and the y, and that's what I kind of need to know. Now, a quadratic function can be used to model the data. Okay, quadratic function, that is important. A quadratic function is y equals ax squared plus bx plus c. I see that it doesn't refer to any It doesn't refer to any form in particular, so I'm just going to choose the standard form. Can be used to model. That means that could be a best fitted curve. So I will need to put all the data. Which value best estimates? Okay, that makes sense. The miles per gallon when the speed is 65 miles per hour. So when the speed, what is the speed? Here is the speed is x. So when x, that's another key word here, the 65 key number. When x is 65, which value best estimates what's miles per gallon? Well, miles per gallon is y. In other words, when x is 65, what is the y? Well, we have some work to do here. First of all, we're gonna put that table, and we have to put the entire table because it's asking us to estimate, so we need to have enough data to do a good job there. And then we'll find this line of best fitted, and then we're gonna go to 65 and see what this line predicts, and hopefully we're close to one of those answers. Okay, let's do this. Table, we have 20, then we have 24.9, 30, 28.3, 35, 29.1, 40, 30.1, 50, 30.0. That 0.0, you may say, why do you write it? Well, when we take data, we have to put 0.0 to indicate that it's actually, we measured it to that accuracy, to the first decimal. It just so happened that it's 0. Okay, so we indicate that we actually did an accurate measurement up to the first decimal. So here's 29.1. Oops. 29.1. Okay, now this is a quadratic, and I'm going to have to ask from the calculator to estimate the best quadratic with a squiggly. A x1 squared plus b x1 plus c, and then we got the ABCs. Okay, and now we can write the quadratic. It's still gonna be the same as the pink line, and let's see how well those data fit on the quadratic. You see that it kind of fit pretty accurately, actually. Now I'm not sure if I go really close to it. If I go really close to it, you see that it kind of misses some points, but it looks like it is a good estimate. Okay, like if you zoom out, it looks like it's pretty good. Now if you go in, you'll see the details. It's not going exactly through it. Okay, let's write this quadratic here. Y equals A is I'm not gonna try to write it because I will have to either put this huge number or something, but what I can do is I will try to locate this x equals 65. So how do I do that? Where is it? It's somewhere here. So if I go up here and tap the curve and uh, move my finger, it's gonna look, I'm gonna be able to go close to 65, but it's gonna disappear. So what's the trick here? Let's type x equals 65. Then it's gonna give you a line. Let's change the color of it, and then once you tap it, you know exactly where this 65 is. You don't have to work really hard to find it. Well, 65 goes with 27.877. So let's see if we have y that's oops, 27.877, 27.877. Let's see which one matches that. And it looks like it's option A, especially since you can round it to the first decimal. And if you round it to the first decimal, that's approximately equal to 27.9. After the 8 is a 7, which is greater than 5, so we round it up. Okay, so 27.9, the correct answer is A. Okay, so let's go to number 14. Researchers studied the population of a town over time and modeled the data using an exponential function. Okay, exponential function, the most frequent and usual form is like that: a times b to the x. And a is the initial value or the y-intercept on the graph. B is the base or the growth factor. This is the number you multiply every year or every generation, depending on what x means. Now we'll see if x goes by month, by day, by hour, by second. Every click you multiply times the growth factor. Okay, the initial estimated population was 48,000. Immediately we know that A is 48,000. After the first year, the population of the town was 50,000. Okay, well, that allows us to actually draw a chart, because initially is 0, goes with 48,000, and after a year, when x is 1, so x goes by year. Every year we multiply times the base. Okay, the first year is 50,400. So we have a chart so far. We have 2 points. If the population of the town continues to grow at this rate each year, which function can be used to model the population x years after the researchers began their study? Well, how am I gonna do this now? First of all, maybe I can narrow down some of the answer choices. A needs to be 48,000, so it needs to be y equals 48,000 and then times b to the x. I don't know what b is, but I see that 48,000 is in 2 spots. Okay, so I can eliminate b and c. It's not gonna be them. Another thing that it's not stated exactly is that it's going up, so it is increasing. Increasing means that the base is greater than 1. Obviously, you multiply with something that's greater than 1 is going to increase. Otherwise, if it's less than 1, it's going to go down. So between those two options, which one has a greater than 1 growth factor? 1 over 50,400 or 50,400 over 48,000? And obviously this is the 1. Okay, but suppose you can't, you don't know this and you can't narrow it down. Let's see how we would use the calculator to get the answer. Okay, so I'm gonna make a table. Oops. I'm gonna make a table, and this table is going to have 0 year with 48,000. Let's see if it likes it, the comma here. I would not risk the comma because immediately gives me the point, the note, the comment to not use comma because it thinks you're trying to put an x comma y. And the first year is 50,400. Now let's see if that's enough data to give me the exponential function y1 squiggly capital A times times B to the x to the x1, and it gives me that A is 48,000 as I expected and B is 1.05. Now let's go here. So the calculator is telling me that B is actually, let's write it properly. I'm gonna take this one, I'm gonna write it here now, y equals A times B to the x. The calculator told me what I expected, that A is 48,000, and it also gives me that B is equal to 1.05. That's also what I expected. It's greater than 1. It's a little greater than 1. And it's 1.05. At the same time, in the two questions that immediately I can narrow down, because this one is not 48,000, that's not 48,000, so those are gone. The two questions, the two options A and D, I don't see a 1.05 in either of them. So what do? Well, take what you got here, put it on the calculator and see if you're gonna get 105. If you get it, that's the answer. If not, take this one, put it on the calculator, and this one should be, just to confirm. Okay, so let's take this one and see if we're gonna get 1.05. The top one was 50,400, and don't put commas, divided by 48,000, and that's 1.05. Okay, so that's the answer. If you put the other one, let's see what would happen here. Of course, I know that the other one, because the denominator is really much, it's bigger than the numerator, is going to be less than 1. It's going to be much less than 1 because the denominator is much bigger than the numerator. So it's 0.000019. It's really small. Okay, so that is not the answer. The correct answer is A. Okay, let's move on to number 15. the graph of the function, number 15, the graph of the function f of x is transformed to form the function g of x, such that g of x is 3f of x, which graph represents f and g. And it gives me several options. So we have the keyword here is transformed, and we go from f of x, we go from f to g. Now f of x is x. This is really the linear parent function, y equals x, and g is 3 times f. Okay, now here I may be able to maybe better to not put the y, and let's see what happens. But keys to things to remember is that you start with f, so that is the parent function, and you go to g. Okay, alright, so let's put that on my calculator and see how I'm going to do. Now before we go to the calculator, times 3 means 3 times taller, so it's going to be steeper. 3 times steeper, the slope is going to be 3 times bigger. So if this is f of x, and 3 times that is going to be 3 times taller. How do I know that? Well, you take this point and you make it 3 times taller. 1, 2, 3 times taller, and then you get that steeper function. Okay, let's confirm that and see if the calculator can figure it out. First of all, I would put exactly what it's giving me. F of x equals x. Okay, now I have I kind of have the parent linear function, or the function that I start with. Then I'm going to write it exactly as it's given. G of x equals 3 times f of x, and it's going to give me the blue line that indeed it looks steeper. And how steeper? Where you see this point here, that's above 1. Now it has gone to 3. Now let me tell you what a point I'm talking about. You see this point here? It used to be there. Now it has gone up, and it's right there. So it's 3 times taller. It used to be, its height used to be 1. Now its height is 3. That's why it makes the line steeper. And of course, if you look at the origin, that stays the same. If you multiply 0 times 3, that's not gonna change, so the height is not going to change. You may ask, why do you multiply the height and not the width? Well, the 3 doesn't multiply x directly. It multiplies, it's outside of the parenthesis. If it was like that, if it was g of x equals 3x, if it was f of 3x, if x was associated with the, if 3 was associated with the x, then I would manipulate the x coordinate, the horizontal coordinate. But because it's not associated with the x, it's on the front, then that manipulates the y coordinate. And just to make a little review here, if it was 3 times x, because the x coordinate doesn't really follow common sense, instead of making it 3 times wider, we would make it 3 times narrower. Now what if it was x plus 3? Then it would be a shift, but you wouldn't go to the right, you would shift to the left. And if it was x minus 3, then you would go to the right. Okay, that's because the x coordinate doesn't follow common sense, as opposed to the y coordinate, that if it's g of x equals to 3, f of x, it's not associated to the x, it's y, then it gets taller. Where if it was f of x plus 3, then you shift 3 steps up. Where if it was minus 3, 3 steps down. So the y coordinate follows common sense. Alright, so let's see which graph is the correct one. It's not it. The lines are parallel. Okay, so that's not it. The second one is not. The third one, it seems, it resembles a bit, but you see G is below F. So it's like that point is getting shorter. It's going down. It used to be at 3, now it goes to 1. So it's the other way around. And the correct graph is what remains, this one, and we can see that this point that has height 2 is going up, and it has height 6. 2 times 3, 6. And also we can, the point that I used earlier, I think was 1. Yeah, I mean it was 1. So if we take the 1 that has height 1, it's gonna become 3 times taller. It's gonna go up. Here it's gonna be 3. So we see exactly what we got on our graphing calculator and what we expected. Alright, so the correct answer is D. Let's go to number 16. What is the quotient? That's a key word. Okay, number 16. What's the quotient represented by the expression for all values of W where the expression is defined? Now, what's the quotient? Quotient also means ratio. Do I have a ratio here? Yes, I have something over something. That's a ratio. So if you take that ratio and you simplify it, you're supposed to find this or that or that or that. Which one? How do we solve this? Well, we can either simplify it. How do we simplify it? We would have to factor that, and then more than likely one of the factors is going to be 2w plus 1, and that would cancel one of the factors, and the factor that remained, that would be this factor here. Or we can just use the graphing calculator during our STAAR testing. And how do we do that? Well, let's see. If this is the same as one of them, I think I accidentally, yeah. If that's the same as one of them, now I kind of revealed it. If that's the same as one of them, that means they are also they're equivalent, because it's the same thing, just one is we have simplified it, and one is after we simplified it, and the other one is before we simplified. So one of them is after we simplified it, and this is before we simplified, but it's the exact same thing, so they're equivalent. So they have the same things, everything, the same chart, the same graph, the same intercepts, the same everything. Okay, so how do we do it? We put it on the graphing calculator, and then we see if they have the same graph. So it's 8w squared minus 20w minus 20. Okay, y equals 8. And I'm going to use w to avoid making transfer errors. Otherwise, wherever it says w, you can just write x. Okay, but I don't have to do that. I'm just going to use what they gave me to avoid making little mistakes in transferring. So 8w squared minus 20w minus 12. 8w squared minus 20w minus 12, and the denominator is 2w plus 1. 2w plus 1, and of course it's gonna give me a graph, and it's a line, because no matter if there's a square in the numerator, it's gonna simplify and it's gonna turn out that it's not a quadratic. This is, if after you simplify there's no squared, so it's a line. Okay, now we go and do the other one. 4w plus 12 and then minus 12. Let's see if any of those is correct. 4w plus 12. Oops. It's not. What if it was negative 12? Oh, and that could be it. That's it. Okay, so it's number 2. It's option B. Okay, let's go to the next one. 17. Which order pair is in the solution set of that? The solution set of this, how do we do that? Well, we have y is less than or equal. So suppose that y is this one. Because it's equal, the line is going to be solid, meaning all the points on the line are part of the solution set, as opposed to when you have just less than but not equal, then we write the dashed line to indicate that points on the line are not in the solution set. So here we would have a solid line. And if that's the solid line, what about the less than? The less than means that we're going to shade underneath the line. Okay, and any point that's in this shaded area, included points on the line, those are in the solution set, meaning if you plug them in with their x and y coordinates, you're going to get a true statement. Okay, and we're going to graph this, and then we're going to see where those points belong to. Okay, let's graph this. How do we graph it? We pretend there is no less than, and we graph it like it's equal, and then we're gonna shade below. Okay, so it's y equals 3 over 5x minus 6. Y equals 3 over 5x minus 6. And we have a line. Now, I can't really graph it on the I can't shade it on the graphing calculator, so I would either have to transfer it to my paper or somewhere on my notability. On the other hand, I can imagine that it's going to be the lower part of it. So I'm gonna plot those points and see which ones is on the lower part or on the line. Let's plot 5, -4 and see where that is. 5, -4. That is on the lower part. That works. That's in the solution set. Let's confirm that the rest are not. -2, -5, and let's see the overall picture. -2, -5. That is above. That's not in the solution set. Okay. Let's label those two. We have 9, 1 and -8, 3. So it's 9, 1 and -8, 3. Let's label those. And we have 3 points above, 1 point below. Okay, and we're looking for something that's either below the graph or below the line or on the line. That is the orange point, the 5, -4. Now, what if you didn't know any of that, which we were not sure which one you shade or how you're going to do it? Well, the point that is isolated, that's the correct one. That's the one that we're looking for. And or the point that's farthest from the rest. And the points that is isolated is the 5, -4, because that's the only point that's underneath the line, so that should be the solution. The other ones are all sort of together on the upper part, and they're all wrong. Okay, so here's the correct answer is 5, -4. And let's move on. Number 18. Which statement about p of x equals -7 4 to the x is true? Okay. The domain is all real numbers greater or equal to 4. The range is all real numbers less than 0. C is the domain is all real numbers less than or equal to 0. D, the range is all real numbers. Well, here I need to see the graph. When it comes to domain and range, I need to see a graph. But this is an exponential. Y equals AB to the x. The domain of the exponential is always all real numbers, because the exponential might go like that, it expands like this forever, it expands like that forever, and eventually if you project, it's gonna cover the shadow of it. The shade of it is gonna the projection is gonna cover the entire x-axis. That's the only thing that you know. Now the range, do you know for sure the domain is all real numbers? The range is going to be above 0 or below 0. So the range is going to start at 0. If it goes like this, it's going to be above 0. But because the exponential cannot touch the ground, it's going to exclude 0. Okay, what if it was a different exponential that was like that? Then the range is going to start at 0 and go down, but the 0 is going to be excluded. And of course you can have an exponential that's decreasing. Again, it's going to start from 0 and up. And if it's like this, it's going to start from 0 and down. Well, we have this in mind, and just if we have this in mind, we can check and see which questions uh, refer to the wrong domain. So let's see, we have domain and domain. Of the domain is all real numbers greater than. We know that this is not true because it's try to restrict the domain. No, the domain is all real numbers unless it's given that yes, it's all real numbers, but I want you to focus on those numbers. If it doesn't give me any restriction in the statement, then you don't restrict. So that's not it. Let's do the other domain. The domain is all real numbers less than or equal to 0. Again, we're trying to restrict the domain, so that's not it. The range is all real numbers less than 0. The range is all real numbers. Well, the range is not all real numbers. Okay, the range start from the asymptote basically and goes either up or down. In that sense, if the asymptote is this line and the exponential goes like that, it doesn't have to start from 0, but it starts from the asymptote. Let's say the asymptote is at 5, then it's going to go up. That's going to be the range. On the other hand, if there was another exponential, that usually the asymptote is on the ground, but if it's not, and the asymptote is here and it goes like this, so the range is going to start from the asymptote, excluding the asymptote height, and it's going to go down. So what do we have here? Just by looking at it, we see that it's negative. So it's going to go down. And we looked at the asymptote is still it's still the ground. It would be shifted. If it was like +5, then it would go up. If it was -5, then it would go down. So it's negative, which is below, and the asymptote is the ground, so it's below 0. Do we have anything like that? Well, obviously it's the one remaining. Suppose you don't know how to eliminate those answers and you don't know how to confirm that yes, indeed, that's B, then we put it on the graphic calculator. And let's see what happens when we put this on the graphic calculator. Y equals -7 times 4 to the x, and we see that it looks like the asymptote is the ground because it tries to go closer and closer to the ground, but it can never touch it. So this is the asymptote. It cannot take the value 0, but it can take all other values less than 0. So the graph looks like that. It cannot touch the ground, so it cannot take the value 0, but it can take all other values of y. We have done so many domains and range problems that I hope now you know that when it says range, it means the vertical axis, and you're going to look for the y and you're going to project on the vertical axis. Okay, so let's go to the next one. We have 19. The graph of the quadratic function is shown on the grid. Okay, yes, that's a quadratic function. That means y equals ax squared plus bx plus c. And what can I tell right away? I see the x-intercepts, which have 0 for the y and 3 in the x-coordinate. Just to keep it simple because I'm not sure what it's asking. Here's the x-intercept, and there's another x-intercept. This one is at 3. This one is -1, and there is a y-intercept, and the y-intercept is 3. Okay. Which statement appears to be true? The best is just to read each statement and see what we think. The function has 3 zeros. Zeros means x-intercepts. Why is that? Because you have the standard form or any form of the quadratic or any function. To find the x-intercept, you need to look on the ground. So you have to set y equals to 0, and then you have the equation to solve and find the x-intercepts. But because you set y equals to 0, sometimes instead of x-intercept you call them zeros. Okay, so it has 3 zeros, meaning 3 x-intercepts. No, it only has 2. The maximum value of the function is 3. Let's look at the maximum value of the function. The maximum value is going to be, in this case, the vertex, which is 4. So that's not true. The vertex of the graph of the function is 4, 1. Oh, okay. Let's say the vertex is right here. The x-coordinate is 1 and the y-coordinate is 4. So the vertex is 1, 4, not 4, 1. Okay, that's not it. So naturally, this is the correct answer. Let's see why. The equation of the axis of symmetry of the graph of the function is x equals 1. Yes, the axis of symmetry is a line that goes like in the middle of the parabola or U-shaped curve or the graph of the quadratic, and it goes through 1. So the equation is x equals to 1 because each point of this parabola has coordinate x equal to 1. So that's what the equation of this line is, and that line is the axis of symmetry. So that's the correct answer. Okay. 20. Which expression is equivalent to square root 600? Well, here we can either do the work by hand or put it on the calculator one by one and see if their value is the same as this value. I can do it real quick here. I'm not going to follow a complete method, but I see that 600 is 100 times 6. I break the square root of 100, square root of 6 times each other, because there is a times between those numbers. And I know square root of 100 is 10. Square root of 6 is not exact, so I'm going to leave it like that. Looks like the correct answer is B. But I may not know how to do that, or I may not want to take a risk. In that case, I'm going to go to the graphing calculator or a calculator, and I'm going to find the square root, and I put 600 underneath, and I have a number. Then the first option was 6 square root 10, the second 10 square root 6. So I would put here 6 square root 10, and once you compare, you see that this is not correct. And then the next option would be 10 square root 6, and you would get the same number, and that would be the correct option. So here is the correct option. Let's go to 21. 21. A line is graphed on the coordinate grid. This is the line. Okay, that keeps going up and down forever. What do I know about this line? Before I even look at the options, I see that it goes through -4. That means all the coordinates of all the points of the line have x coordinate equal to -4, and this is the equation of the line x equals -4. Now, this is not really a function, okay, because it fails miserably, this vertical line test. If you put a vertical line, it's not supposed to cross in more than 2 points. It crosses in an infinite number of points. So this is not a function. So it can't have this form, because this is a function. Okay, the y equals mx plus b is a function. This line is not a function, meaning in particular, that means my line here cannot have a slope, cannot have the m. The m is the slope. It can't have a slope. I can't define a slope. The slope is undefined. So I can write it here. Slope is undefined. It's so steep that it looks like the slope it's infinitely steep, that because it goes vertically up, and we can't define with a number and infinity, so that's why it's undefined. That's another reason to think of it. Okay, now let's look at the answers. A, the equation of the line is x equals -4, yes. And the slope is undefined, yes. So that's A. Let's see why the other ones are wrong. The equation of the line is y equals -4. No. Y equals -4 would be this one. That all the points on this line will have height, or y equals to -4. That's not my line. Okay? My line is vertical. This line here is horizontal. And the slope is equal to -4. And in this case, if I take the -4, the slope will be 0. So it's wrong both ways, because they gave me the wrong equation, and the slope of this would be 0. The slope of my line is undefined, so both statements here are wrong. The equation of the line is x equals -4. That's good. And the slope is equal to -4. No. This -4 refers to the point that the line crosses the x-axis. The slope is undefined. The equation of the line is y equals -4, and the slope is undefined. Well, the slope is undefined, the slope of my line, but this is not the equation. And the slope of y equals -4 would have to be 0. So, but I was liking the first option. The first choice was the correct one. So let's move on. 22. The graph of a linear function. Okay, linear means y equals mx plus b. F is and we have the graph. Okay, the graph of a linear function f is shown. Okay, what is the 0 of f? Again, when it says 0, that's the x-intercept. Why is that? Because here's my linear function. To find the x-intercept, you have to set y equals 0. And then if you solve this equation, you find the x-intercept. Because we set y equals 0, to find the x-intercept, we call the x-intercept 0 of the function. Okay, fine. What's the x-intercept? Well, it's right there, and it's 2. And it's C, the option C. So maybe they're testing whether I know the name of the x-intercept and whether I can read a graph. Number 23. What is the solution to the system of equations? We have a system of equations and we have 4 options. Now, in the previous In a previous video, um, we kind of solved each one of those for y, because basically if we can have a line for this one and a line for this one, wherever they intersect, here is the solution. That point, those coordinates, those x comma y, if you plug them in for x and y, you're gonna get two true statements, and that would be the solution. So but your graphing calculator at STAAR cannot graph anything unless it's y equals. So we would have to isolate y, and I'm gonna do it this way here, but I also gonna do it a different way that it may be actually preferred, because you're not doing any algebra. So I'm gonna go really fast on the first way because we have done that before, but and I'm going to show you how to do it on the graphing calculator without algebra. So first let's do some algebra. We're gonna start with this one and isolate y so we can graph it. The first thing that we do is we add 3x, because it's the 3x is in the same side as the 5y, it needs to go. And when we do this, we get 5y equals 3x plus 21. Then we divide by 5. Canceling, we get y equals, I don't need to simplify or break this fraction, it will still graph it. My graphing calculator will still graph it, no matter what's on the right hand side, it doesn't matter as long as y is by itself. Then let's do the other one. Y is here. Let's get rid of the 6x by subtracting, and we're gonna get negative y equals negative 6x negative 15. Oops. And then y is not by itself, it has a negative. That's basically negative 1 times y. So I'm gonna divide by negative 1. Cancelling, I get that y is equal to negative 6x negative 15 over negative 1. Now I'm going to put each one of those on the graphing calculator and find where they intersect. If they don't intersect, if they are parallel lines, there is no solution. And if they are identical lines, there are infinite solutions, because each point is a solution. Alright, 3x plus 21 over 5. Y equals 3x plus 21 over 5. Let's double check and get the other one. The other one is negative 6x minus 15 over minus 1. Negative 6x negative 15 over negative 1. Let's double check. Negative 6x negative 15. Alright, so I got two lines. Where are they? Well, here they are. You tap the house on the house key is on the right top, and it will get you there if you are not. So the intersection is negative 2, 3. Okay, so x is negative 2 and y is 3. Let's see if there is such an option. Negative 2, 3 is this one. Okay, so we find it. But now I'm going to show you another way. Okay, no matter what, you should be able to isolate an unknown. You should be able to isolate y. Okay, but there is another way here, and we're gonna do another way. How we're gonna do this other way? Like let's write those equations that we had at first. Negative 3x plus 5y equals 21. I'm gonna change the color now. We have negative 3x plus 5y equals 21. And the other one, 6x minus y equals negative 15. Okay, this is what we were given. I'm gonna try to use the graphing calculator to test all these values. Like I'm gonna plug those in. Plug is for x and y, for example, and if I get the true statement in both, then it's the correct one. Otherwise, then I'm gonna go to the next one, then to the next one until I get true statement. Let me show you how this is done. One way is to be like, okay, I'm gonna put -3, then times 2 plus 5 times 27 equals 21, and see, is it gonna be equal to 21? But that's a lot of work. Let me show you a short way. First of all, if you want to do this faster way, you have to change the x and the u. Let's change them to a different letter. -3u plus 5v equals 21, and 6u minus v equals -15. If you do it this way, then the graphing calculator is going to plug it in for you. So let's put -3u plus 5v equals to 21. Have -3u plus 5v equals to 21. U, there's nothing special with u and v. You can choose A, B, C, D, anything. Okay, now we're gonna do the other one. 6u minus v equals -15. 6u minus v equals -15. Let's double check. 6u minus v equals to -15. Okay, back to the calculator. Now let's see, we have some remark here. We only support implicit equations of x and y. So it looks like this is not, he doesn't understand it, thinks we want to graph it. So to help that thing, let's get rid of the 21, and let's get rid of the -15 and the equal sign. Now let's see what the message says. Too many variables, try defining u or v. Now I have to define u or v. Okay, let's try to define u or v. Let's say that u is that and v is that. So let's put u equals and v equals. Okay, now I'm gonna go and check the options one by one. Okay, first is 2,27. So I'm going to put u equals to 2 and v equals to 27. Immediately it's going to give me an answer. You see at the top two tabs, now I have an answer. But I also expect, I want it, but is it true or is it not true? I have to compare those numbers with what I expect. The top one should be 21. How do I know that? Because it needs to, the top needs to be 21, the bottom needs to be -15. So that is not 21 or -15. Now I'm gonna change the numbers. I think the next choice is -2 and 3. And when I put this, the second option, -2,3, I get 21 and -15 in the top two tabs, which is what I expected. So that would be the correct answer. Okay, so what happened with this method? Just take the equations given and then change the letters. Don't put x and y. And then plug in, give your calculator values for those new variables, for u and v. You may say, oh, could I have done it with x and y? Let's see. If you put x and y, it doesn't give you the option to give variables. Okay, as opposed to when you put u and v, it's going to tell you you have to define u and v, but it doesn't ask you to define x and y. So you have to change the letters from x and y to something else. U, V, A, B, C, D, anything. Also, E is not a good letter to use because E means something else. It's the base of the natural. Anyway, it's related to some exponential base, and it is a symbol like the pi. It's also a mathematical symbol. So don't use E, don't use X, and don't use Y. So no X, no Y, and don't use E. Any other letters you can do. 24. Which expression are equivalent to this one? Select two correct answers. Now, that's a problem here, because if you don't read this statement and you find the first correct answer, you may miss the second one. Okay, so read it carefully. The key word here is equivalent and two correct answers. Okay, equivalent means they have the same graph. Two of them, some of them, they're going to have two of them is going to have the same graph as this one. Now, does this make sense? Well, yeah, because I have three quadratic forms. One is the standard form, which is this one, y equals ax squared plus bx plus c. And another one is the factor form, the other one is the vertex form. So I have three expressions, and then I can always have something that doesn't exactly classify as any of those expressions, but if you simplify it enough, they all look the same, and if you go all the way to simplify it as much as possible, that you're gonna get the standard form. Anyway, how do we solve that? We plug it in the graphing calculator and we see what happens. Let's do that. Y equals, and let's start with 12x squared minus, I'm tempted to not do that because it's really simple, but let's do it. 12x squared minus 48x plus 48. Y equals 12x squared minus 48x minus, what I don't remember now, was minus 48 or plus 48. Plus 48. Okay, we have the first graph. Now let's do the next one. It's 12x minus 2 squared that's not it, because actually it could be it, because we have only one intercept, and when you see a perfect square that has one x-intercept, so that's one of them. And negative 12, and then I have x squared plus 4x plus 4. That's going to have the wrong signs if I distribute, so that's not going to be it, but let's put it negative 12 and then the other ones. Okay, so x equals negative 12 x squared, oops, yeah, plus 4x plus 4. That's not it. I may have put some extra plus sign here. The next one, it's not gonna be it because it has two different factors, so it's gonna have two x-intercepts, and I saw that my given quadratic has only one x-intercept, but let's see it. 12 x minus 4x minus 1. Oops. So we see that it's not it. Then negative 12x plus 2 squared. Okay, you see immediately that this one, the green one, has 2x intercepts. Mine has only, oops, 1, so that's not it. Y equals negative 12x plus 2 squared. Y equals 12x plus 2 squared. Yep. We are we need to make this negative. I need to make this negative, and it's not it. So it should be the last one should be correct. Oh, and they give me 5 options here. Okay, so it's 12x squared minus 4x plus 4. X squared minus 4x plus 4, and of course it's the same. Let's change the color of it. And of course it's the same as expected. Okay, so the correct answer was A and E. Alright, how could I have done this without a calculator? I would have to take each option and do PEMDAS basically. So all the parentheses are gone, and then they will look like their corresponding standard form, and if the corresponding standard form is the same as the given one, that would be it. We have done those, of course. Now if you want to do that to this one, let's say you get 12x minus 2 x minus 2, then you have to distribute and you get 12x squared, and then you have x times negative 2 is negative 2x, negative 2 times x is negative 2x, and the last one, negative 2 times negative 2, is plus 4. And immediately you see one more step, then you have 12x squared, negative 2, negative 2x, negative 2x, negative 2x, those are like terms, they can combine to negative 4x plus 4. Immediately you see that this is the same as that, so it's because it's part of converting it, and I go from one equivalent to another equivalent. Like in a sense, this is also equivalent to my given function, this is equivalent to my given function, and so on. But what do I do next? Then I'm going to distribute the 12. 12 times x squared is 12x squared, 12 times negative 4 is negative 48, and the x follows. 12 times 4 times positive 4 is plus 48. You can do all these multiplications with a calculator if you can't do it. And we see that what we got after we did PEMDAS or simplified is this one. Okay. Yeah, I could show you actually the PEMDAS because it's kind of fun to see. First I start looking at that, Do I have parentheses? Yes, but I can't do anything. Do I have exponent? Yes. Can I do it? Well, no. All I can do is expand it. Okay, let's do PEMDAS here. Parentheses, yes, but I can't do. Exponent, no. Multiplication, yes, I have a multiplication here and there. I'm first gonna do this multiplication, and it's done by distributing. Then I go here. Let's do PEMDAS. There's no. Is there a parenthesis? Yes. Let's go inside the parenthesis. Starting over. Is there a parenthesis inside the parenthesis? No. Exponents, yes, but I can't do it. Multiplication, yes, 2 times x, 2 times x, but I can't do it. Division, no. Addition, subtraction, yes, those two, and that's combining like terms. Then I'm done with the PEMDAS inside the parenthesis. There's nothing else to do. So let's start over. PEMDAS for that step. Parentheses, yes, I can't do. Exponents, it's inside the parentheses really, that it's part of I can't do because I don't know x. Multiplication, yes, let's do it by distributing, and I'm done. Well, I just wanted to mention it real quick. That's part of some work we have done earlier, and when we do things by hand, and there are videos on that. But here we'll just plug in, put it on the calculator, and whichever have the same graph, those are the equivalent ones. 25. Which quadratic function in vertex form? Okay, vertex form. Now, what is the vertex form? This one, y equals ax minus h squared plus k, where h and k are the x and y coordinate of the vertex. Can be represented by the graph that has a vertex at 1,46. So the vertex is 1,46. That is my h and k, and passes through the point 3 tenths, and this is the vertex, and there is a point 3,10. That's just a point that the line passes through. I can't do it by hand. I can plug in the h, k, and then I plug in, and then I will know h, k, but I won't know a, and I can plug in the point and solve for a. And you can do it this way. Here we are preparing for the STAAR test, and I'm going to try to minimize doing work by hand. And instead, I'm going to plug in one by one and find the vertex and see if they go through the point 3,10. Whichever has vertex 1,46 and goes to the point 3,10, that is going to be the answer. Okay. I mean, I could narrow it down a little bit if I assume that we remember and we know this during the test. Immediately I can see that the vertex is 1,46 and it needs to go for h and k. So 1 is h. This one doesn't have 1 for h or 46 for k, so that's not gonna be it, and that's not gonna be it. It's either B or D. And here we would have to plug in the point. Like we would know that this form, but this would be A for us. We wouldn't know what it is. And what we would do, we would plug in 3 for x and 10 for y, and then we would solve for A, and we would see what the value of A is. If the value for A is 9, then it's this option. If the value for A was negative 9, then it's this option. Okay, here I'm just gonna plug in on the graphing calculator, and I know that it's not gonna be A and it's not gonna be C. If you don't know, then plug in all of them one by one, but I'm gonna just plug in B, and the one of them is correct, the other one is not. Okay, let's plug it in. Y equals, let's start with a 9, x minus 1 squared plus 46, and it's somewhere here. We tap the vertex, and it's indeed it's at 1,46. Now let's see, we have a point 3,10. Where is that point now? 3,10 looks like it's kinda hard to see, but I can either tap my finger and see where the 3 is, and I see that the 3 is somewhere here, but it's at 82. Another way to do it is just put x equals 3, and then it's gonna give you the intersection. So that's a, and of course another way would be to type y equals 82, because you know either of them. Okay, but just x is enough. So you know that it's not it, so it's the other one. Oh, well, another way is also to do a table and get rid of all the points and put a 3 there, and it's gonna give you, either way you do it, you'll see that 3 goes with 82. We want it to go with 10. So it should not be this one, it's the next one. Okay, it's the next one. Let's plug in the next one. It's the same as the one that I got, only it has a negative. And let's see how things change now. First of all, let's find this intersection. That's 3, indeed is at 10. If I want to do a table, and let's get rid of all the other points and put a 3, you see that it also goes to 10 on the table. And if I do this, and if I plug in x equals 3 and find the intersection, or if I tap it and slide my finger, either way, if we see that the correct answer is D. Okay. Now 26. The table shows the number of customers each hour from an online sale. And we have the x and we have the f of x, which really is y. Which function best models? I'm looking for a best fitted. Best fitted what? Is it going to be a line? Is it going to be a u? What is this going to be? Let's see. Which function best models the data? They don't tell me anything about what I expect, but I can look at the options and I see that it's supposed to be a line. Why is that? Because that, let's take the first one, that looks like it's y equals b plus mx. It's kind of written backwards. You can also write it mx plus b, which is the most familiar version. And you need to know this if you're going to use your calculator to models it successfully, or at all. If you don't know what to put on your graphing calculator and you want to use the squiggly method, which is what we're gonna use now, you're not gonna, if you don't know what to ask for the calculator to do, the calculator is not gonna know by itself. So let's use the squiggly method here. We start by putting some data, and I know that it's from 1, 2, 3, 4, 5, 6, 7, and now let's see what we got. 296, 256, 296, 256, and then we have 215, 170, 133, 215, 170, 133, two more, 89, 51, 51. Okay, you see that that's the x1, y1, so I have to write it as x1, then my squiggly, m x1 plus b, and I have my slope m is negative 41 point something, and the b is 337 point something. So roughly negative 41 and 337. Now let's see which one gives me that. Negative 41 for the slope is the first and the second, so that's not, the C and D are not in, and 337 is B, so here's the answer is B. Okay, let's go to the next one. The function W of t is equal to that can be used to estimate the number of whales in North Atlantic Ocean at the end of t years. So I know that t counts years. What does 1.029 represent in this function? Well, let's see what we know about exponentials. This is of the form y equals a times b to the x. A again is the initial value, and on the graph is the y-intercept. B is the base or growth factor, anywhere you call it, whatever you multiply by this number per year. And why I say per year, because the exponent represents years. Now the exponent is they call it t, but it doesn't matter. You can call it t or you can call it x. Okay, so they're asking me about the base. Is it what is that? What is the base represent? And I know this stuff. So let's see. A, the initial number of whales in the North Ocean. Well, the initial number is A, and A here is 270. It's not 1.021. So that's not it. The decay factor, well, growth factor, sometimes called decay factor if it decreases. But I know that when b is greater than 1, it's going to be an increasing factor, and when b is less than 1, it's going to be a decreasing factor. Here this base is 1.029 is greater than 1, so it's not going to be decreasing. So when it calls it decay, I know that that's the wrong way to call it. Um, Sometimes a growth factor represents a decrease. If you can say that, oh, this is a decreasing growth factor in a sense. But decay factor is also another way to call the base when it decreases. Okay, the decay factor of the number of wells in the North Atlantic Ocean. That would be correct if instead of decay factor you call it a growth factor or increasing factor or base. If it was any of that, that would be correct, but now it's not. Then the number of the wells in North Atlantic Ocean at the end of the first year. uh, no, the number of the wells at the end of the first year, you have to take the initial value and just multiply times the growth factor. That is not 1.29. Okay, it is two. It would be it would be 270 times 1.29. Okay, so that's not it. Then it would be the last one, which is the growth factor of the number of wells in the North Atlantic Ocean, which is the same as B, but instead of decay factor, growth factor. And how do I know it's a decay or growth? Well, it's greater than 1, so it should increase. So it should not be a decay factor, okay? Because 1.029 is greater than 1, which means it's increasing, which means it's growth, not decay. Okay. Although, as I said, sometimes we say it's a growth factor, increasing growth factor or decreasing growth factor. Sometimes you call it like that. But when you just say decay, that just means decreasing. All right. And let's see. Let's see how quickly we can do a couple more. 28. A line contains those points. What is the slope of the line? I'm just gonna use the squiggly method, or we can use the rise over run. We can plot those points, do the rise over run, or because when we say slope, we can find it by hand. If we measure the rise and the run, then we divide it like that, rise over run. Or we can use this formula, y2 minus y1 over x2 minus x1, which x2, x1, x2, y1, y2, those are the coordinates of those 2 points. For example, you can take x1, comma, y1, x2, comma, y2. And you plot them here. For the rise over run, you would have to plot those 2 points. This is the negative 2, comma, negative 2, comma, negative 2, and the 4, comma 2 is here. You would have to measure the rise, which is 1, 2, 3, 4, and it's positive 4. That's the rise, and then the run, which is 1, 2, 3, 4, 5, 6. And let's write here that this is the rise, this is the run. When we divide rise over run, we'll see that this would be 4 over 6. When we simplify, divide by 2, we see that this is 2 over 3. And the correct answer should be C. Okay, but you see I have to do a little bit of work, and if you don't trust yourselves in figuring out the signs here, or measuring the boxes, or plugging in here, maybe I should plug it in just to, because it has some negative numbers there. What would be y2? 2. Then minus, and y1 is negative 2. So you would have to plug in negative, negative. Okay? And what about x2? x2 would be 4 minus, but x1 is also negative, negative 2. And then you would see that would be 2 plus 2, because negative times a negative is positive. Negative times a negative is a positive, or you get 4 plus 2. And then you would have 2 plus 4, 6 over 2 plus 2, I mean, I miswrote the top. Negative, this one, negative times a negative is positive, but then it's 2. So then you would have 4 over 6, and you would simplify as before to 2 over 3. So any way you do it, you will get 2 over 3. But suppose that you're really tired or something, or you just want to confirm. I'm going to do the squiggly method here. For the squiggly method, you're going to need a chart, and you're going to put those points in your chart: negative 2, negative 2, 4, 2. And you're going to ask your calculator to find you that line, and it's part of it is going to give you the slope. But we need to know the form of that line. So we're going to give our calculator this form: y equals mx plus b. And we're going to use this chart. Let's see if we can do that. Let's do a table that has negative 2, negative 2, and there was one more point, 4, 2. 4, 2. Let's see what this equation is. y1 equals m x1 plus b. What? Oh, somehow something got erased here. So let's go back. I'm not sure why it erased that. Okay. Oh, I see what I did. Let's go back. You see what I did? I did not put a squiggly, and it can't figure it out. So here it's gonna give me that the slope is 0.666 and the y-intercept is negative 0.666. Okay, that's the y-intercept. But the slope here is a decimal. What will I do? Let's see if I can convert it into a fraction. And if I put it exactly like it is, it has 1, 2, 3, 4, 5 sixes. 1, 2, 3, 4, 5, and then I put a 7. Try to convert it to a fraction. That doesn't look like what I got. The reason why is that it's really a rounded decimal. In reality, it keeps going like this forever. And if you give it enough sixes, it's gonna realize that, oh, okay, that's what you mean. So my calculator rounded it, converted it into a decimal, rounded to 0.666667. But in reality, that's the 2 over 3. And you can convert it back to 2 over 3. Now, if you cannot convert it back, if it gives you some number that is not easily converted back, then you just have to do the work. Okay, just find the rise of a run or something. But usually you will be able to do it. So the slope is 2 over 3, and that's what I wanted. Okay, let me look at the y-intercept. The y-intercept is also the same number, but it's negative. So the y-intercept will be negative 2 over 3. And the equation, if I wanted to write the equation of this line, this equation would be 2 over 3x minus 2 over 3. But I care for that number, which is the slope, and I would choose C. And that agrees with the two calculations that I did earlier to find the slope. Okay, I think I'm gonna do one more. I'm just gonna do one more, and we'll continue next time. Alright, 29. What is the solution to the equation this equals to that? Is it this, is it that, or that? Well, if I want to do the work by hand, I would take this equation and I would solve for y, and I would figure it out. How would I solve for y? I would follow a method that tells me first do PEMDAS to the left, then do PEMDAS to the right, then use properties of equalities, the addition and subtraction, to move things from left to right and right to left, trying to put all the w's together and all the numbers together on the other side, and then use properties of the equalities, which is the multiplication and division, to sort of get rid of the coefficient of w. That would be one way to do it by hand. Another way, if I didn't have a graphing calculator, I could take this one and plug it for w here and there. And if you find, and then you do PEMDAS to the left and PEMDAS to the right. You don't have to do the rest. If you find the same results, like let's say 10 equals to 10, that is the correct answer because it satisfies the equation. It gives you a true statement. If you find 10 equals to negative 8, for example, that is not the correct answer because it gives you a false statement. Okay? And you can, how would we do that? The calculator can do it, but you'll have to give the left hand side separate. For example, you have to type 5 2 times 5 over 2 plus 4, and then your calculator will give you an answer, and then put the right hand side 4 times 2 times 5 over 2 plus 9. Put that exactly on the calculator and it's going to give you the answer if you don't want to do the PEMDAS by hand. Okay, so we have a couple of ways, but we have a graphing calculator during the STAAR test, and I'm going to use the graphing calculator. To do the graphing calculator, you take the left hand side and you write it like that: y equals 5 to w plus 4. You take the left hand side and you write it like that: y equals 4 to w plus 9. And each one is going to give you a line, and wherever the lines intersect, that's the solution. If the lines are parallel, no solution. As I said, the intersection is the solution. And if the lines are one on top of the other, then there are infinite solutions. So let's do it this way. Let's go to our graphing calculator. Y equals 5 times 2w plus 4. Y equals 5 times 2w plus 4. It's gonna give me a line. Now let's do the other one. The other one was 4 to w plus 9. Y equals 4 2w plus 9. Well, where do they intersect? If you look here, like, oh, maybe they don't intersect, they're parallel. But if you zoom in, and in particular if you change the scale of the y-axis, you see that they actually intersect, and the solution is 8 for x and 100 for y. But what is w? What is it, 8 or 100? Well, w plays the role of the x, so the solution would be 8. Let's see. Yes, I have an 8 here. That would be the solution. Now I'm gonna show you something before we move on, or before we end. If you don't put the y, sometimes I've seen people don't put the y there, and if you don't put the y, it can actually not graph it. You would have to actually change the w to x, and then it can graph it. Okay, but you don't want to change too much from each problem, so I want to write it exactly as it's written, and always put the y equals on the front, because this is first of all, this is how proper math is written, with the y equals when you try to write a function. And second, because if you forget and you put a 2w plus 4, for example, there, and it can't graph it, and you don't remember that, oh, I have to put a w there, it's going to be a problem. Now, let's see what happens when you don't put the y. You always look at the message. Try adding y equals to the beginning of this equation. Okay, if you forget or if you don't know what's wrong, try to read the message. I think I'm going to stop now. I hope the video recorded, and I hope you can hear the sound as clear as my little microphone allows, and we'll continue next time.